Okay, for this particular thing, just so that you guys know, yesterday we did graphing, or we solved by graphing, or we solved by substitution, right? Remind me, how do I solve by graphing?
Just do it.
How? Y equals, you put it in, you hit graph, then you go to number 5. What would number 5 say?
Wasn't it something with interpret?
Close.
Intercept.
Intersection.
Oh, intercept.
And then you would find the intersections based on those, right?
Yes.
Okay. So, here's what the problems are going to look like. They're going to be very similar to that. The only difference is we're going to do it the same way, but there's one thing missing. Okay, that looks like one of the problems. The problem with this is that it does not look like yesterday's work, does it?
No, not at all.
What's different about it from yesterday as compared to today?
There's no Y.
There's no y. There's not a y in this problem at all.
Not at all.
Okay, so if I asked you to use graphing to solve this, there's two ways of doing it. One of the ways, you've already done it, and that is move everything to one side, make it equal to 0. Then you can plug it into the calculator and see where it crosses the x-axis. That's one way. That would be using the zeros feature on your calculator. But there's another alternative to actually moving everything, and that's doing this. The left side is y1, and the right side is y2. Okay? So the first thing that you're going to do, just like yesterday, turn the calculator on, go to y equals, you type in x squared plus 2x on y1. How do you do negative 1/2?
-1 divided by 2
Yes.
x squared.
Can I write it like that?
Yeah.
Okay. X squared plus 2. That would be in y2. And then again in y1 you would have x squared plus 2x. And then what do you do once you have both of those loaded in? What do you think you do now? What did you do yesterday?
So,
You pressed graph, right? And you saw what they look like. And by the way, what these look like, I have one coming in here like this, and I have another one coming in here and hitting it like that. That's roughly about what they look like, or at least that's what Kristen got on her calculator. Is that what you guys got on your calculator, for those of you who typed it in?
Yeah.
Now, what you're asked to do is just like yesterday. Now we're going to try to find the intersection, where they cross, where they hit each other. So, intersection, second trace. Down to number 5. How many times do they hit?
Y once.
Looks like once, okay? What'd you guys get? Now, some people that did it have an ordered pair of 0, 0. Now, let me explain something to you real fast. You guys, at the beginning, I asked you what was missing, and you said the y, right?
Yeah.
Is there a y in this problem, in the initial problem, at all?
No.
No. So guess what doesn't matter?
Y.
Right, because it's not in the initial problem. So my only answer for this is not necessarily the ordered pair, it's just x equals 0, because in the initial problem, there was only x's. Now, when you do this, be careful, because sometimes the problems don't say 0. Like I'm looking at Kristen's big screen, she has 0, 0 as the intersection. Paige had 0, 0 at the intersection. Marie didn't have that yet because she's still learning.
It's okay, Marie. We'll learn
But
about these.
Danny had,
Not that.
here's what she had. She had 5.714 e to the negative 13th.
That looks nowhere near correct.
Okay? Now, is she wrong?
No.
No. Yesterday I told you what that number meant. Here's what her calculator did for her. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5, 4, 1, 7. That's 0. It just made, because it couldn't put a pixel directly on 0, 0 for your problem. It's not wrong. You just have to realize that when you go back towards the back end, it has to be where, if it says e to the negative anything, that's 0. Okay?
Always.
Yep.
Always.
What do you think?
No exception.
Those are right.
Now, what if there's more than one crossing?
I have no idea.
I don't know.
What if it intersects twice?
I have no idea.
Then you do it twice. Now, here's something that you have not used yet. In your calculator, loaded right now, is what they call a viewing rectangle. In the viewing rectangle, this goes 10 in every direction. Okay? On the regular one that comes straight out of the factory, it goes 10 in every direction. When I asked you guys to hit zoom standard, I'm asking you to put it back in the regular window. This is the X maximum because that goes the maximum on the x-axis. This one is the x minimum because that goes left. This is the y max because that goes up. And this is the y min because that goes down. Some of your pictures are not going to fit on your window. You're going to see that they should cross, but your windows are not going to be the right way. So what's going to happen is that you use either a couple different features on your calculator. One of them is zoom out. That could help. Another one is the window button. If you hit window, it comes up with this menu. It says X min, X max, X scale, Y min, Y max, Y scale. X min stands for left, so if you need to move it to the left, you adjust that number. X maximum, it moves it to the right. The scale, have you guys ever had to make a line graph or bar graph before in your past where you had to go up by tens or hundreds?
Yeah.
That's what the scale will adjust. If you don't change that, let's say you go from like negative 40 to 80, that's 120 little tick marks that it would put on there. If you want it to not look so bold, then what you do is you change that so that you have a different number, like each of them go by 5s or by 10s or something. You don't have to change it if you don't want to. The Y minimum would adjust it if you need to go down, and the Y maximum would adjust it if you need to go up. That's what adjusts it. Okay? Now, realistically, this window stuff, just so that you guys know what this means. The windows and setting up a proper window to see it, as long as you see the intersection, it's good. Danny could get a different window than Blake, but could they have the same answer?
Yeah.
Yeah. Realistically, I have 110 people doing the same type of problem. Could I have 110 different answers
Of course you could.
for the window, but all have the same end result? Yes. Okay? So, with that particular thing, you might have to adjust the window. So, let's do another one.
One teacher's not allowed down in the classroom. One teacher wouldn't allow come in the classroom. We'll just take the bus.
H, you need it.
Oh, yeah. So we just type it into our calculator.
Go.
This is something about shovel.
Okay? So, looking at this problem, when I type that in, left side is Y1, right side's Y2.
Yes.
Yeah, don't need to. You're just doing it in the calculator anyway.
might as well just plug it all in. You just put it all into y equals.
I know I do.
Like each side of the
But then I
equal
don't know
sign.
how to.
You type so. Okay, Tate just got a syntax error on her calculator. What that means is that she typed something wrong.
You're alright.
And what happened was, in front of the 6x squared, she put a minus instead of a negative.
It's okay. Okay. We all make mistakes. Especially Adrian.
Okay, so looking at Danny's calculator right now, here's what she saw in her window. So if this is her window right now, she's got the blue one that comes down like this and comes back up this way. And then she's got a red one that's doing this number like this. Is that a good window?
Yeah.
No, it's not. Because it's going to hit twice. I see one down here, but I need to have another one somewhere. Which direction do I need to move the window?
Left.
Down.
Oh.
I need to go down because it looks like eventually this blue and this red is going to hit down there. So what you do, hit the window button.
And a Y minimum.
You need to adjust the Y minimum. How far down do you want to make it?
Let's do -80.
Negative 80. Does it matter what number you change it to? No. You just have to see if it works.
So press enter that.
Then you press graph after you've typed it in. Now, just so that you guys know, setting a proper window is not an exact science. Danny suggested going down to negative 80. It doesn't necessarily mean that's going to be the right one. But, judging by her reaction, she got a window that can see both of them now. So now she's got a window that she sees this one coming here and this one coming in there. So now she actually sees both intersections. How do you find the answers now?
You press enter.
You hit second,
Just do second trace.
second trace, intersection,
Press enter twice.
enter 3 times in a row.
1, 2, 3.
And what number did you get? For the X. Remember, the Y doesn't matter.
2.4.
Now, what I want to know from you on that one, Danny, because you told me 2.4. Was 2.4 the one on the left or the one on the right?
Left.
That's this one?
Yeah.
Okay? So now we've got this one done. How do I get the right one now, Danny?
Move it.
I hit second trace, option 5, and then I move the cursor closer to that other point and then hit enter 3 times. And what'd you get for the other one?
Enter. X equals 6.5.
Okay?
6.6.
So my two answers were 2.4 and 6.6. I do not need the y coordinates. They're not in the original problem, so therefore you don't use them. That's how you're doing the entire assignment today. Okay? So on page 137, 44 to 50 evens.